If you ever heard the terms like ETL, ELT, or ETLT and wondered what's the real difference is, don't worry, you are not alone. At first, they can sound complicated, but the idea behind them is actually very simple. They all answer one important question, that is, when does the data transformation happen in the data pipeline? In this video, I will break that down step by step. So let's get started. Here is what we will cover in this video. First, we will understand what ETL, ELT and ETLT actually mean. Then we will walk through ETL using a simple concept and a data flow example. After that, we will do the same for ELT as well. Next, we will look at ETLT, which is the real world hybrid approach, and that's often used in the production system. Then we will compare these three terms and highlight the key differences between them. And finally, I will share you how to choose the right approach for the real world projects. Before we go deeper, let's first understand what these terms actually mean. These terms are not tools, they are patterns that describe when the data transformation happens inside a data pipeline. ETL stands for extract, transform, load, whereas ELT stands for extract, load and transform. And ETLT is a hybrid approach that combines both of them. At first glance, they might look very similar, but they lead to very different ways when it comes to building and running data pipelines. In every data pipeline, data needs to be extracted from the source system, needs to be transformed into a usable format, and then finally that gets loaded into the central location so that it can be used for the dashboarding or the reporting purposes. Here when I say data processing, I am mainly talking about data transformation, which means cleaning the data, joining the data, shaping it into a usable format, and depending on the project, the data size and the requirements, the order of these steps can change. And that change in order is exactly where ETL, ELT and ETLT come from. So instead of memorizing these terms, we will focus on understanding why and when each approach is used. So now let's dive into each one of them. Let's start with ETL first. To understand ETL, let's first look at a simple real-world analogy. Imagine you are making fruit juice. First, you extract the fruits from the tree. Then, before anything is delivered, you transform those fruits. Like you clean them, you sort them, you convert them into a fruit juice. Only after that, the finished juice bottles are loaded into a truck and sent out for delivery. So, the key idea here is that all transformation happens before loading. Now, let's map the same idea to a real-world data pipeline. First, the data is extracted from the source systems. It could be databases, files, or JSON data. Next, the data is transformed outside the data warehouse. For example, using Python scripts to clean, join or reshape the data. And finally, the transformed data is loaded into a data warehouse like Snowflake. This is the classic ETL approach where data is cleaned and prepared before it even reaches the data warehouse. ETL works very well when the data structures are fixed and the transformations are well defined, and you want only clean and ready to use data to be stored in your data warehouse. Now that we understand what ETL is, let's see how things changes with ELT. We will use the same fruit example here as well. But notice how the order changes. First, fruits are extracted from the tree. Instead of turning them into fruit juice right away, the raw fruits are first loaded into the truck. After they reach the destination, then they are transformed into a fruit juice. So in ELT, the transformation happens after loading, not before. Now, let's map this to a real-world data pipeline. First, the data is extracted from the source system. It could be databases or files. That raw data is then loaded directly into the data warehouse. For example, here is Snowflake. And once the data is inside the data warehouse, the transformation happens within the data warehouse itself. And tools like dbt are commonly used here because they help to transform the data inside the data warehouse. And transformation is basically cleaning that data, joining that data, reshaping that data. So, ETL works especially well with modern cloud data warehouses like Snowflake, Redshift, Google BigQuery, where the storage and compute are scalable and flexible, so that it allows teams to store raw data first and decide how to transform it later as the requirements evolve. Next, we will look at ETLT, the hybrid approach that combines the best of both these worlds. This approach combines ideas from both ETL and ELT. Let's start again with the fruit example. First, fruits are extracted from the tree. Before loading, there's an initial transformation like cleaning the fruits, sorting them by their type. Then those partially prepared fruits are loaded into the truck. And once they reach their destination, there's a second transformation happens where the fruits are finally turned into different fruit juices. So in ETLT, transformation happens twice. Once before loading and another after loading the data. Now let's map this to the real-world data pipeline. So the data is first extracted from the source systems such as databases or JSON files. An initial transformation happens outside the data warehouse, often using Python, to clean the data, handle the errors, or apply basic business rules. Then that data is loaded into the data warehouse. For example, Snowflake here. Inside the data warehouse, a second round of transformation happens using tools like dbt to model the data for analytics or reporting purposes. So ETLT is very common in real-world production system because it gives teams flexibility, allowing early cleanup wherever needed and then deeper transformations later inside the data warehouse based on the requirements. Now let's compare these three terms side by side and see the differences between them. The most important difference between these three terms is when and where the data transformation happens. In ETL, the data is transformed before it's loaded into the data warehouse. That means transformation happens outside the data warehouse and only clean, structured data is stored. ETL works well with smaller data sets and legacy systems where the data schemas are fixed and predictable. In ELT, the order changes. The data is first loaded into the data warehouse and then the transformation happens within it. This approach is more flexible and scalable, and it is commonly used with modern cloud data warehouses. Now, ETLT sits in between them. Some transformations happen before loading and additional transformation happens after loading. This makes ETLT ideal for real-world production systems, where the data is complex and requirements keeps on evolving over time. A simple way to remember this is, when it comes to ETL, clean before storing it. When it comes to ELT, store first, then clean it. And finally, when it comes to ETLT, clean twice for different types of needs. Next, let's look at how to choose the right approach for the real-world projects. The first thing to understand here is there is no single best approach. The right choice depends on your data, your requirements, and your system. If your data volume is small to medium, the structure is fixed, and you want to clean the data before it gets stored, then ETL is a good fit. You will often see this in legacy systems or data pipelines with strict schemas. If your data volume is large or growing fast, you want to store the raw data first and then do the transformations as they change over time. ELT usually makes more sense here. This is common in modern analytical setup using cloud data warehouses. And if your pipelines are complex, different teams need data at different stages, or transformations are needed or required both before and after loading the data, then ETLT is often the most practical choice. This is why ETLT is very common in real-world production system. So instead of asking which approach is best, ask which approach fits my use case. Once you think about it this way, the decision becomes much clearer. I hope this video gave you clarity. If you found this helpful, make sure to subscribe for more videos like this. Thank you.